Let's take a look at the slope-intercept form of a line, which is y is equal to mx plus b. When your equation is solved for y, the coefficient in front of x, that value of m, will be the slope of a line. And we like to say b is the y-intercept, but technically the y-intercept is the point 0, b, because a y-intercept is a point at which the line intersects the y-axis. Now we are being asked to identify the slope and y-intercept of these first few equations, and in the first couple, the slope and the y-intercept are readily available to us. In the first problem, the slope is 3 and the y-intercept is 0, -5. In the second problem, m is equal to 1/3 and the slope is 0, -4/7. So very easy to do when the equation is given to us in slope-intercept form already. In problems 3 and 4, something is missing in each. In 3, you've got the mx, but you need to understand that there's a plus 0 at the end, so your slope will be 5 and your y-intercept will be the origin, which happens to be the x-intercept also. In the next problem, when you look for y equals mx plus b, it appears the m is missing, but there's an understood 1 in front of the x, so the slope is 1 and the y-intercept is 0, -9. When the equation is not in slope-intercept form, you need to convert it to slope-intercept form, and that means isolating the y. So we will begin by subtracting 3x on each side and writing this as 7y equals -3x plus 11, and then dividing each side by 7 to have -3/7 x plus 11/7. So the slope here is going to be -3/7, and the y-intercept is going to be the point 0, 11/7. That is a key skill to be able to perform. Let's do yet another one. Isolate the y. Begin by subtracting 2x on each side, and then divide each side by 5 to get y equals -2/5 x plus 3/5. It is then you can identify that the slope is -2/5 and the y-intercept is at 0, 3/5. In problem number 7, there is no y equals, so you know that something strange is going on here. It turns out that this is the equation of a vertical line at x equals 7. And as you can tell, there is no y-intercept, and the slope is actually undefined. Anytime you have a vertical line, the slope is undefined. This is because when you're looking at the rise and the run of a fraction of the slope, the run is 0. The rise can be any two numbers depending upon which 2 points you choose to count the rise between. But whenever you divide by 0, you know we use the word undefined, and so that word is reserved for the slope of a vertical line. A standard problem is to ask whether two lines are parallel, perpendicular, or neither. And if the equations are already in slope-intercept form, all you need to do is examine the slopes. The lines cannot be parallel because the slopes are not the same, and the lines cannot be perpendicular because these are not opposite reciprocals of each other, but only opposites. So they have neither a parallel nor perpendicular relationship between them. In the second problem, the slopes are 1 and -1, which are negative reciprocals of each other, and so the two lines are perpendicular to each other. And I think it's quite easy to see that we have the same slope on number 10, and so these two lines are parallel. The slope-intercept form of a line is very useful for graphing a line. All you need to do is identify the slope and the y-intercept. Always begin with the y-intercept, which in this case is 2, and plot that y-intercept on the graph. Then look at the slope and count out the rise and the run. Here the slope is -3/5, so we're going to rise or go down -3 and run 5 units to the right. to get to a second point, and through those points you can then draw the line, and it will be accurate, and you do not need any XY charts. Let's do this again. Identify the y-intercept to be at 0, -3. This line has a slope of 1/4, so we can rise 1, go up 1, and run 4. And then we have 2 points through which we can draw our line.